Throughout our history, physics has played a significant role in the development of society through multiple discoveries that have allowed advances with technological and useful applications. Much of what is known in physics has an impact on our lives. Some developments are gradual, such as improvements of solid-state physics leading to more powerful computers, whilst other developments appear unexpectedly, such as the development of X-rays, which now have many uses in medicine. Welcome, my name is Ariana Cornejo, and I'll study physics. There have been several discussions on data fabrication, a blatantly wrong practice that consists of reporting made-up data, going against the integrity and the natural objectivity of research, and its purpose of describing phenomena and structures that make up our world with exactitude.
So the next question arises. To what extent is leaving the integrity of research results aside a violation of ethics?
A very common issue is the selective reporting of data to deceive. Not fully reporting the attempts to carry out an experiment can lead to cherry-picked data to support one's hypothesis. American sociologist Robert King Merton, known for founding the sociology of science, stated 4 principles of scientific practice. 1. Communality, which means public disclosure of results. 2. Disinterest, referring to no personal interest in the result. 3. Skepticism, which supposes that scientific conclusions are always open to question. 4. Universalism, which is associated with the pre-established criteria for truth. The rules from these principles include accurate and full reports of theory and experiment with complete and correct data, no omission of unexpected results, objective interpretation of data, and fair credit related to authorship or citation.
Following the American Physical Society guidelines,
selective reporting of data with the intent to mislead or deceive is an egregious departure from the expected norms of scientific conduct. There are multiple reasons for these behaviors. The most common ones are 1. Pressure and financing. Financial help is often limited and not easily accessible in science, and it is usually determined by one's good reputation on the publication of good scientific papers, because successful publications draw attention to sponsoring institutions.
In 2012, an article published in the newspaper The Guardian suggested that
increasing competition for shrinking government budgets for research and that disproportionately large rewards for publishing in the best journals have exacerbated the temptation to fudge results or ignore inconvenient data. 2. Reproducibility and proofs. Some experiments are not easy to reproduce, and results are affected by noise, artifacts, and any other factor, which means that a scientist who falsifies information can hope to get away with it, or claim innocence if the results contrast sharply with those of others in the field. Moreover, although investigations are carried out by experts in science, they actually lack of such expertise in combating criminals.
One of the most controversial cases is the measurement of the charge E of the electron by Robert Andrews Millikan
in 1910 in his oil drop experiment, which consisted of introducing droplets of liquid into the electric field and recording the strength of the field necessary to keep them suspended. In his paper on elementary electric charge and Avogadro constant, he mentioned that his measurements were not a selected group of drops, but represented all of the drops experimented, but he only reported 58 observations out of 175.
This opens a debate. To what extent can data selection be considered as manipulation or good scientific intuition? Under what conditions can data be rejected?
On the one hand, reporting on every experimental failure would increase noise without adding much value to the results. And on the other hand, having unlimited flexibility to decide whether data can be included opens up a possibility for biases.
It is therefore important to use accepted statistical tests and remark data exclusion in reported results. For instance, Chauvinist criterion,
which is a method to calculate the probability of experimental data being an outlier. Aside from that, publication and authorship issues are also frequent.
Talking about the same case, it is crucial to mention that the discovery was double-authored. Millikan knew exactly that the determination of the charge of the electron would give him a solid reputation in the scientific community. Thus he made a one-sided convenient agreement with Harvey Fletcher
to have Millikan appear as the sole author of the paper, which would allow Fletcher to be the sole author of the article on the determination of Avogadro's number.
Even though the deal was not to Fletcher's liking, he had accepted as Millikan was his mentor.
Despite the determination of the charge of the electron being one of the fundamental reasons for Millikan to receive the Nobel Prize, the two maintain a good relationship. This practice comes from people who are driven by greed and hence present a reduced empathy, usually due to the desire of getting fame and recognition. Selfishness, only thinking in the sake of oneself and forgetting about the others, makes individuals prioritize status, wealth, and feeling their own pride rather than their moral principles.
Now, it is time to make an ethical judgment on these issues by applying ethical principles from different perspectives. We can analyze selective reporting of data from a communitarian view.
According to philosopher David Hume, we are motivated to act benevolently,
but we need limitations, and that's where rules come into play. Thus the question is, what is the effect on the scientific community and the public?
Unethical behavior leads to compromising the advancement of science, as it makes the community spend more resources and funds than necessary. It also generates increased public distrust of science. And we can analyze publication and authorship issues from a utilitarian view. The theories supported by philosophers such as Jeremy Bentham determines right or wrong depending on the outcome. Utilitarianism maintains that the most ethical choice will produce the greatest good for the greatest number of people.
The matter is to analyze the effects on each party, specifically the scientist who takes advantage of his position and the scientists who are affected by receiving incorrect or no accreditation of their work.
What does the Catholic social teaching say about this issue? The Compendium of the Catholic Social Teaching, also known as CST, refers to the scientific methodology. In Caritas in Veritate encyclical, translated as Charity in Truth, the CST positively values scientific and technological knowledge as a creative human activity. It also acknowledges that science provides useful, necessary, and valid knowledge.
Furthermore, some related principles of the CST highlight the importance of
1. The common good, which explains that society wants to be positively at the service of humanity. It requires serving and being fully served, assuming responsibility and not following selfish views. 2. Fundamental values that include truth, freedom, and justice. Truth, as people have the obligation to respect and bear witness to the truth. Freedom, that is seen as the ability to reject what is morally negative. Freedom exists truly only when reciprocal ties regulated by truth and justice unite people. A very sensible quotation from Libertatis Conscientia in 1987, translated as the consciousness of freedom. After all, what is the actual solution for all these problems? Education is an essential means to reduce the incidence of these issues that violate ethics in science. The existence of courses that cover responsible conduct of research and ethical issues related with the interaction of physicists with society has the goal of leading students to take a thoughtful approach to analyzing ethical issues, making students aware of why standards exist and apply them in real-life situations. In the long term, a better and more aware investment of countries in the scientific field can also be seen as a solution, especially in countries that are still in process of development, since science will allow them to progress. It is not a matter of giving unreal badges, but of viably increasing the efficiency of its use. It is vital to take these solutions into account for time optimization and resources used in carrying out experiments, increase the number of high-quality research, and to prevent other scientists from accepting unfair and arbitrary conditions regarding authorship. To sum up, science is best advanced when there is trust built up from honesty. Unethical practices are inadmissible,
as they have detrimental effects not only on individual physicists or organizations, but on the credibility of physics throughout the world.